and I'll post the video after lecture. I have to upload it. So, as I said, welcome. Welcome to ECGR 4124, 5124, Digital Signal Processing. I'm the instructor of this course. My name's Andrew Willis. I've been instructing this course for quite a while now, and I've been here in the department, the ECE department, for 17 years at UNC Charlotte. It seems like everything that has to happen at once, doesn't it? So I'm going to go ahead and get rid of this. And so these are the realities of the pandemic. The things that, for those of you that still have landlines, they're not easily moved nor turned off, so to speak. And yes, in fact, I still have a landline, which is interesting. So yes, about myself. Let's see. I've been here in the department for 17 years instructing courses, and at this point, I'm an associate professor in the department, and I'm also the associate chair of the electrical engineering program, and I'm the director of the undergraduate programs for the department as it stands right now. So I've been doing research in signal processing for over 20 years at this point, and so I'm very familiar with the subject area. And I enjoy the subject area. However, we must realize the subject area is not typically an easy area to study within. It's a very sort of math-centric area. So in the course of class today, we're going to discuss the syllabus for the class, the structure for the class, and you'll have an opportunity to ask any questions you might have about how the class will be conducted. Then we'll have an opportunity to go through the lecture slides for the class, which, usually I don't get through the first lecture, sort of this class orientation slide stack all the way, because going through the syllabus, there's usually a lot of questions, but we'll see what happens. So having said that, just like any class that's online, and of course we're online for the first 2 weeks until January 24th, and hopefully we're back in person after that. We'll have our lectures online until then, and we'll have office hours online until then, and everything will be online. After that, the expectation is to shift back to face-to-face. So with the online content, and we mentioned this at the beginning, just a little bit before we started recording, is that the Canvas course is ready to go. So I'm going to pull up the Canvas course here on another tab. This is the Canvas course for our class. It has these modules here that you see. Now, you'll see for me on my, you'll see a lot of modules visible that you do not see as visible. So those modules will become available as we go through the content of the course. You should see these first two modules, the course information module and the week 1 intro to DSP. In week 2, we'll be doing discrete functions and sampling and fundamental theorems. But for right now, we're just going to talk about the meeting times. You already know the meeting time in terms of lecture. It's right now, 1 to 2:15. So 1 to 2:15 on Tuesday and Thursdays. I've got our midterm scheduled for March 1st. Tentatively, I'm hoping that we'll be in class. So I'll describe to you the nature of how we conduct midterm and other examinations when we talk about the syllabus in more detail. Again, my name's Andrew Willis. I'm the instructor. My office location, if you're looking for me in person, I'm up in the front. I'm in the administrative offices. So you go into the main office of ECE. So you can't walk down the hallway and get to my office door. You have to go into the ECE front office. And the undergraduate director has allocated a space to the right there of the chair's office. So when you go to the front office in ECE, there's a big desk there. There's a door on the right, and that's Epic 2356. That's my office. Jin Chang has already been chatting with you folks. Jin Chang, did you want to introduce yourself? Jincheng?
He already did, Professor.
Okay. Well, thank you for introducing yourself, Jincheng. Jincheng is a student here in the department, and he's also one of my research PhD students. So he's been studying here at UNC Charlotte for some time now, and he's the you're lucky to have him because he's an excellent TA for this class. He's TA'd this class, I think, at this point 4 times. So he's extremely familiar with the topics, and he can be a very good asset for you to do well in the class. So the plan is to have him make himself available about 4 hours a week for you folks to come and meet with him and work on, just ask him questions, whether it be working on homework problems or projects or getting ready for examinations, whatever it is that you have, you can come to him. My office hours are scheduled for after class, so right after class. Right now they're scheduled in Zoom. Zoom doesn't allow scheduling on the 15-minute interval, so my Zoom office hours start at 2:30. But when we go back to face-to-face, it'll go to 2:15 to 3:15. So those are my office hours. So this just tells you general information in the course. So the midterm exam date has already been set, but the final exam date is yet to be determined. We don't have the schedule from the registrar for that yet. Any questions on this information as it stands? All right. So I hear resounding silence, so I'll assume that we're fine there. Okay. So let's see the textbook. So the textbook for this class is there's an ISBN for it, and you can get it from Amazon here. It's Oppenheim and Schaefer's Discrete Time Signal Processing, and it's available. You can rent it apparently for $74 as it stands. You can buy a paperback for $86, or you can go for the full hardcover book. And so that's going to be our textbook. Let's see. So having covered the basics of the meeting times and the people involved, let's go ahead and review the syllabus as a whole. All right, so here's the class syllabus. We're going to be talking about these topics. Everything you can see is a focus on discrete time. So this is digital signal processing. We're going to be dealing with the discrete time functions and all of the theory related to processing discrete time functions, and also the topics related to transforming functions or signals from the analog space into the digital space and then back into the analog space. And that's a real focus for this class. All right. What are the prerequisites? So all folks here should have passed 3111 Signals and Systems with a C or better, where they talk about these topics and others. And let's talk about the grading, which is sort of what students are most really important for you to know that. The grading for the course is divided into these 5 areas. So the midterm and final examination add to 40% of your grade. They're divided equally as 20% apiece. Then the quizzes are worth 25%. The homeworks are worth 15%, and the projects are 20%. We should have two projects over the semester, and we have about 9 quizzes over the semester, and the same number of homeworks over the semester. That's typically how this class runs. If you are in the 5124 section, this 5124 is the graduate section for this class, and so you can expect extra work on assignments, in particular on the projects, and perhaps in other locations, certainly for that class section. So there's a bunch of additional stuff relating to the pandemic and all these many other topic areas after the syllabus, which is just part of executing a course these days, whether it be online or otherwise. And I don't know if I'll need to go over all of those things in detail. As a senior level course at the university, I understand that saying these things is probably just redundant. So if you have questions about this, so Eric, did you have a question about MATLAB? I see a MATLAB statement.
Oh no, I was just answering Zach Matheson's question. He was asking if there's any software equipment we need for the projects, and I said MATLAB was
Oh,
going to be
okay,
the.
yeah. Thank you for that. I sort of missed Zach's question. Sorry for that. So Zach, yeah, there is MATLAB. MATLAB is actually an intrinsic part of this class. You can, for every lecture, you'll see a MATLAB chunk of MATLAB code that goes along with it. And that I'm sharing with you my MATLAB code so you can see how that MATLAB goes together and how the actual, in many cases, the MATLAB I'm sharing with you is in fact the very MATLAB I wrote in order to generate the slide materials that you're provided. So the stuff that you see in the slides, you'll have the MATLAB code that essentially generated it, so you'll know, you'll have examples of how these plots are made, how some of the calculations are done, and things like that. So this talks about the COVID-19 situation. Assignments are not accepted late. This is something I should read. Assignments submitted late or on...
All right.
Hello? Assignments submitted late online or in any form, email, papers, or to the TA. Yeah, you bet, Zach. So you're going to become... everyone's going to build up their MATLAB muscles in class. So assignments submitted late, online, or in any form to the TA or the instructor will not be acknowledged. You need to turn in your stuff when it's due. If you need an extension for some extenuating circumstances, you need to communicate that with me, not with the TA, with me, the instructor. The TA is instructed not to accept work that's submitted late. So if you say don't copy me and decide to contact the TA directly saying I'd like to turn this in, that is not an acceptable path of conduct. Anything that's late, if you have a discussion about it or if you seek to try and submit it, that would go through me, not through the TA. If you have extenuating circumstances, i.e. circumstances that are different from every other student in the class, you need to contact me with those extenuating circumstances and allow us to have a discussion about that. All right, so online learning, this is something I need not actually go over. Grading. So this is a significant portion of the courses are graded by TAs. As such, your first point of contact when you have a grading concern on a project, quiz, or homework or other assignment is the TA. When the TA and you are unable to resolve an issue, you bring that grade to me, and I will make the final decision on any grading. So all grading questions should be brought to the TA first, and then to me if you can't get resolution with the TA. So anything that you bring to me directly in terms of grading, without consulting the TA, I will just tell you to go and talk to the TA. This is the path of action for these things. So calculators, this is a little bit for online courses and in online circumstances. This actually I've been allowing students to use MATLAB. So this whole thing about not calculators is actually something that I will update and actually calculators will be allowed. This is something I had intended to remove but haven't yet because
Doctor.
yeah.
Quick question on this. Sorry to interrupt you. So is that going to be the same thing for exams? Calculators allowed or no calculators in the exam?
I plan to allow. In fact, so we should talk about that too. So yes, calculators will be allowed. In fact, I am encouraging every one of you to become familiar with using MATLAB. And MATLAB is actually going to be allowed to be used during your examinations. So you can use your MATLAB during your exam.
Oh, wow. All right.
And if you want to use a calculator, you can use that too. But realize that if you decide to use a calculator when other people are using MATLAB, I'm not sure that you're giving yourself an advantage there. You might be crippling yourself. So exams are not going to be given online. So thank you for all these questions. These are fantastic to see all this interaction. I have a question from Seth Hensley saying, does that mean the exams will be online? The exams will be on Canvas. If we are face-to-face, they will be in the classroom. Does that make sense? So you will go with your laptop to Epic 2222, which is our classroom, and take the exam there. And so I have a protocol there about how the exams will be. So when you come to the exam, you'll come there with your laptop, and I've actually gotten some extension cords so people can plug in. That's a big room, and so that people can, because MATLAB actually uses up some juice. No, you cannot make pre-make MATLAB scripts. You do not have everything available to you. You have the ability to use MATLAB. You can't write your own materials and answers in MATLAB and use those. So Mikey, to be clear, you can't. It's not a open book exam where you bring in anything that you want. You can bring in a blank MATLAB, and you cannot run any of your own stuff on there. You would have to write MATLAB code during the exam to help you. I hope that clarifies that situation. So you'll have available what are the materials you have available during the examination? You have all of the slides that are in Canvas. So you'll have the PDFs of all of the slide stacks, and I write usually an index if you want to know about convolution. That is lecture, because when you go to the Canvas course, you'll see it's organized by topic, intro to DSP, but it just says lecture 1, right? And so students, maybe you need to know like what is lecture 1. That's the introduction. So it'll say, I give you an index, like lecture 2 has this in it, lecture 3 has this in it. That way, if you're looking to index and look at those materials, you have a quick way of which PDF to look up. And so what you have access to is what you see here. You don't have any additional materials other than the PDFs and the MATLAB that you have right here. And is that clear? So go ahead. So an MLX5 is a MATLAB live executable. All right. And so an MLX file is a file that you can open directly in MATLAB. And I'll actually demonstrate so I am actually encouraging these days to people to use MATLAB online. But you need not do that. You can install MATLAB on your very own computer. But I'll show you how to open an MLX file. Maybe I should just go ahead and do that right now. So I'm going to go to matlab.mathworks.com. I already have an account here. You may not have an account, in which case you'll see maybe something like this. I'll sign out, and so I would have to sign in. And if you don't have an account, you'll have to create one. I would click on create one. But I do have an account, so I'll go ahead and type that in, and then I'll go with here and I'll type in my password, and then I'll go ahead and sign in. And now I have this, and you can see that I have a bunch of folders and files here. So I have a folder dedicated to this class, and if I were to look at that folder, it's going to load up the content of that folder. And it'll actually start opening code and so forth. So I actually had the pleasure of teaching this class last semester. So as you can see, some of the lecture materials from the end of last class are already opened. And it kind of shows you some of the things, how lecture kind of unfolds. And this is lecture from the end of it's like lectures from December. But lecture 1 is right here, lecture 01.mlx. That's the file that you can download right here. And if you were to go to files, there's a section there under MATLAB where also you can just download all it's all available. Like you've got all the way up until lecture 17 available here. So it's all there. You can go ahead and download it if you like and start playing around with it, but it's just there. In terms of opening an MLX file, you would have to upload it. So I've already uploaded mine. But there's a MATLAB drive, online drive. So once you create an account on MATLAB Online, you'll have a drive allocated to you, and then you can go to there's all sorts of applications. But if you just use I'm going to go to the Drive Online, and this is like you think of it like Google Drive, right? This is MATLAB's version of Google Drive. You can go here and you can go into. I think I'm in this folder right now, and you can upload stuff. I could take stuff off of my computer and then drag and drop it up here, or I could say upload and then say upload a bunch of files and then choose the files and upload them. So hopefully, Zach, does that help you like in terms of like getting started with MATLAB, how to get those MLX files up and start using them? Okay, yeah, so fantastic, great. So Zach says he's already got it open, and I'm just going to double click on lecture 1 myself, since we're here, and everything else is open. I'm going to try and close some of these other things. MATLAB Online, by the way, it does use up a lot of CPU, so it's pretty hungry, and it will make your browser kind of it's a little bit slow. At least on my computer.
Excuse me, Dr. Willis. I joined you mid-sentence to start. Did you say we have to watch the lectures before class, or that you just said they were available for us?
No, you need not watch the lectures before class. No, that's
Gotcha.
not a requirement. You certainly have them available to you, and that doesn't make sense to. So all of this materials that we put online, I'm happy. I want to share them with you. So if for some reason you're unable to attend class, you can either watch the lecture that we had in class, such as today, which will be recorded and placed online for any class that we have online. For the classes that are in person, the technology, we don't have the recording facility there. Sort of that's a shortcoming. So for any class that's online, you'll have the lecture itself on the video, as well as the corresponding lecture from 2020, I think from fall of 2020, and for any class where we have lecture actually in person, like in Epic 2222, you'll have the lecture from fall of 2020, but I cannot record the lecture in that room, so you won't be able to have the recording from the actual in class. And classes do differ in terms of the pace and some of the actual specific subject areas. So it's the best I can provide.
Thank you.
Yeah, thank you. So let's see so here's lecture 1. So it has finally opened. I can probably start closing these other tabs if it'll let me. It doesn't look like it wants to respond here. Everything seems to be coming up. Well, I'll just refresh and see what happens. I've taxed MATLAB Online pretty heavily these past. I guess they actually all did close, but I just didn't update for me. So you can all see my MATLAB Online screen here, and you should be able to reproduce this as well. So you should be able to download the MLX and create a MATLAB account and upload it. And if you wanted to, you could use it online and have you could edit this stuff and do what you like with it. It's those are your files to go ahead and experiment with. Okay, so I've digressed a bit, but let's get back to the syllabus and finish up that part of today's lecture.
Dr. Willis, you have a question in the chat box.
Okay.
Two, actually.
Yeah. Okay. Sorry about that, Amin. Are the homework problems MATLAB problems? Sometimes they are. Sometimes they are, and sometimes they're not. Most of our homework problems lean towards the theory, but and MATLAB is really focused on in the projects. But sometimes there are MATLAB related questions or things that you have to go to MATLAB and use MATLAB to get the answer. So is MATLAB a tool that helps us with calculation? MATLAB is both a tool for calculation as well as a tool for solving problems. So it's an important component to the course I'm in, and so it's important for both answering questions, following lecture, and doing all of that. Thank you for your question. I hope that answer was sufficient. So let's see. Let's get back to the syllabus, folks. So the syllabus states this for that for the grading, and we talked a little bit more about the specifics of grading. Talked a little bit about calculators. That'll be updated and removed. In fact, let's just go ahead and remove the calculators thing right now, since we're talking about it. So there we go. And so such and done. Okay. So attendance. So attendance. Often there's questions about attendance. Let me tell you this. This is a senior level course. This is 4,000 level course. You are all senior level undergraduate students. You're preparing to enter the workforce. This is going to be one of your last courses before you actually are conferred a degree. What does this? To me, that means that you are your own. You make your own decisions. Whether you attend a lecture or quizzes or examinations is completely and entirely up to you. Attendance will not affect your grade. I think it's an important part of success, for sure. But if you decide not to attend lecture, or if you decide to get up and walk out during lecture, as long as you're not disturbing class, that is your own prerogative. If you decide to arrive a bit late, that's also your prerogative. As long as you don't disturb class, I have absolutely no problem with that. No problem at all. So
if we end up having things that conflict with class time, I noticed that you say that you're not going to like repeat lecture material during office hours, but if you have like a legitimate reason for why you can't attend class and you plan for it ahead of time, how can you make up missed material covered in class?
So yeah, and Zach, I think it gives the answer. I would also repeat. So there's you have recorded lectures as a source of information, which previously wasn't available. So I think that the answer to that is if you're unable to make class for whatever reason, then it's your responsibility to make up the material for those classes. Even if that reason is an excused reason, these classes have to be conducted at a specific time, and if you have reasons that are excused reasons, then you will have to make accommodations for making up the material within those lectures. And so you have an abundance of materials there, and so you'll have the video lectures, and you'll have all of the online content. So you'll have all of the slides. And after I go through every lecture, I annotate the lectures as I go through slides. Hopefully we'll get to that point where I start to do the annotations. But I sort of have it open here to just give you an idea. So, you've all seen it. I'll go ahead and write on the slides as I go. And then at the end of the class, I'll go ahead and save those and upload them. Once we finish the lecture. Sometimes we go halfway through and I wait until we go through the entire lecture and upload it. So those are your avenues for getting information if you don't come to class. I suggest coming to class. Again, that's how universities work. You go to class and that's the place where you have the opportunity to learn the material, have someone guide you through the material. There's no capability, there's no bandwidth to represent the same material over and over, depending upon how it fits schedules of individual students.
I've got a question about the class. So how does this class relate to like a class like controls or something like this? Because we had to take systems before that, and for controls you take systems as well.
Right. So in the larger curriculum for electrical engineers take 3111 just as all the computer engineers do, which is signals and systems, or also called linear systems. Now the electrical engineer students typically take 3112, which is right after 3111 and before 4124. All right, and so this talks about root-locus concepts and Laplace domain stability and things of that sort. And so controls, and sometimes they talk about state transition matrices and linear models for state transitions. So those things are so control theory is your what are you trying to do? And this is really a great question to lead into, like, what is this class about? What will you learn? I wish we're sort of getting a little bit ahead of what would be in the slides, but controls are about how can you provide inputs to obtain desired outputs, right? And so controls has a perspective. You develop models of the world, mathematical models, and then you develop mathematical models for how you can provide values for inputs that will achieve desired outputs. That's what controls is about. And at the same time, you're trying to make sure that the systems that you're working with for the controls, that they call them control laws, like you come up with laws about how you want to do control. For example, I want to drive my car and stay in the lane. You know, that's like a control law. And then you want to make it stable. So, you know, you have to do stability analysis. You want to make sure that if you have, you know, any small corrections, they don't actually go haywire and sort of grow in amplitude, and you get cars that are swerving left and right. And these are kind of behaviors that happen from unstable systems. Those are all control-related concepts. Signal processing is a bit different. In signal processing, the fundamental goal of a signal processing course is to let us understand signals themselves. In this course, we'll be talking about analog signals from the continuous world, like my voice, the acoustic signal, being transduced into digital signals, such as the audio file that's being created from the microphone that gets transduced into a digital signal, then sent across the internet, then converted back into an audio signal and emitted through a loudspeaker so that you can all hear what I'm saying. So that's that process of taking the signal, converting it to a digital signal, and then converting it back into an analog signal is one of the fundamental goals of this digital signal processing course, is understanding the transformations that occur there and understanding how signals are affected by that transformation. So that's a significantly different task that's being accomplished in this class from like a controls class. Does that help clarify?
Definitely.
Okay. Yeah. So we're going to learn about that. Any other questions while we're having a chat? Okay. Yeah. So attendance is not required. Reading and videos. So every one of our classes, you'll see has you can do preparation. You can, in fact, watch the video before class of the same lecture from beforehand. It's not required, but for each lecture, there's also related textbook readings. So in this pre-lecture reading assignments and topic list and video content, this is all the stuff that you can do in order to prepare for the content that will be given to in a given lecture. And so you can tell what will be in the lecture in terms of both. You can both look at the slide stack, and then you can also look at the list of what are the important concepts related by this bulleted list of things that are in the lecture. Finally, you can find the related reading from the textbook at this bottom bullet for each one of the lectures that tell you what from the textbook corresponds to what we're talking about in the lecture itself. Excused absences. So if you're missing some kind of a quiz or something, that's on you unless you have an excused absence. So there's there's very straightforward ways to just report excused absences. If there's some kind of trouble there, go ahead and have a chat with me. Just communicate with your instructor, okay? If you have a disability and you have not sought out the Office of Disability Services, seek them out now. Make sure you have your accommodations met. So they will communicate back to me any students in the class that require accommodations, and we will make sure those accommodations are met. Class disruptions, we don't want them. That's basically what this is about. Just don't disrupt class. Try not to be disruptive. You get a warning, but if it's chronic, then it will go to the next level. But I've never really had to. The students have always, there's been some outbursts, but there's never really been a problem there. Don't post the course, the content, your solutions, or anything like that to Course Hero or to Chegg or anything like that. This is not, this violates copyright law, and fundamentally it's just irresponsible as a student to be doing so. So don't do it. Let's see. You should also be aware that PDFs and things that get downloaded from these online sites actually can be watermarked, and when you re-upload them to places like Chegg and Course Hero, they can be marked with your personal information. And so there is, it's becoming. I just warn you. Just don't do it. Please don't do it. And not only that, even if you do it, it's becoming to the point where they are putting technologies in place to trace this stuff, just like they did for DRM, digital rights management. There was a whole issue with music, being shared, and the copyright laws relating to music, and they put DRM stuff on that, and that's a signal that they included in the digital, in the music itself. It's signal processing, so they put a little. And now they put watermarks on stuff. Watermarking is an interesting signal processing problem where they introduce subtle variations in the actual signal you could never detect because they're extremely or 1-bit variations. So they only change 1 bit in the signal at every value. But when you have a million of these measurements, you can actually detect the pattern of those bits even when they're perturbed. And then discover hidden information inside of these files. So, you should be aware of that. Computer use in the classroom, as long as you're working on computers that's related to class, don't come to class and play your favorite video game. It's not a good idea. Don't do it. And if there's a sexual harassment, a Title IX compliance thing that the university is having all faculty include with their syllabus, it's just not tolerated. No sexual harassment at all. All right. Any questions about the syllabus?
I have one, Dr. Willis.
Yeah.
So considering how things are, just out of precaution, if we do go online per se, would the course really change in any regard to what you have templated?
The course would actually be very similar. The changes will have to be made. Like the whole thing I'm telling you about how I conduct exams, it presumes that we're going to be in person. So I would be lying were I to say the course is going to be exactly the same. But the content of this course is structured to be online, primarily online. There's the homeworks are quizzes given in Canvas, and so are quizzes. And so I guess that's the answer I have for you. Does that make sense?
Okay. No, yeah, absolutely great. Thank you.
So I have a question in chat. Will we be getting the slight guidance to the project along with the expected outcome? Okay, so in terms of a project, I am not going to provide an answer to the project as part of the project. So, because when you do that, I found that that's exactly what some people submit. And then we have, it actually raises more academic integrity problems than it provides academic learning solutions. So that will not happen. But guidance there's actually for project 1, there's an entire lecture dedicated to guiding you through how to go about solving it. So for sure you'll get guidance. Also for sure you will not get the answer. Okay, so hopefully that answers that question. And I think that covers. I think for me that covers homework solutions. So homework is given in Canvas and their quizzes and the quizzes. So let's talk about that. Yeah, let's talk about the pace of the pace of the course and how these. I mentioned that there's 9 quizzes, and there are 9 homeworks, and so. And I'll get to your question, Zion, in just a moment. So the pace of the course is as follows. We issue so we go over a lecture, and then contemporaneous to the lecture, you'll be having a homework assignment. Yeah, all the quizzes will be declared ahead of time. So Andy, in response to your question, will we get a heads up on quizzes? Yeah, there's no pop quizzes. quizzes when the homework is due. So with very few exceptions, whenever the homework is due, you're taking the quiz at the beginning of class on that same day. And so sometimes homework gets extended, and that means that the quiz date is also extended. If there's any variation from that, we will declare it and tell you that explicitly. So, and the pace of the course is as I was saying, is as follows. You'll get this homework assignment. Typically, you'll have a week, sometimes 10 days, to work on the homework assignment. And then when the homework assignment is due, that's typically the same day, and actually it's typically the same time. It'll be due at like 1 on a Tuesday or a Thursday, and then you'll have a quiz for 15 minutes on the quizzes. So no quizzes are dropped. Multiple attempts are not possible. That's not exactly true for all of them. There have been circumstances where, but don't plan on having a multiple attempt quiz. The quizzes are meant to assess your understanding of the information. So you have the homeworks. A lot of the homeworks will have multiple attempts on them, but the quizzes are assessments of your knowledge at that point in time. So you need to have prepared for the quiz, studied for the quiz, and execute on the quiz at the time that the quiz is given. And so that's the structure of the class. So there are no quizzes dropped. There are no quizzes dropped. No lowest quiz. Everyone gets graded according to all of those things. So if you're unable to come to some quiz, then that's just you will have a 0 grade. That's all that there is to say. That's an assessment, and there is no lowest grade dropped on the quizzes. Let's see. That tells you the pace of the course in terms of the homeworks and the quizzes, how they are paired up. A project is assigned right around the midterm, typically right after the midterm, and the next project is assigned a few weeks later, just before, and you have a few weeks to complete that before the end of the course. It's the timing of the projects. Of course, we have our first exam on March 1st, and then a final exam whenever the university schedules that final exam. We'll find that out about midway through the class. There's been a lot of excellent questions, and I hope that the answers I provided are clear. But is there any other questions before we transition to chatting about the lecture content?
I had a side question, Dr. Willis. Maybe this is already getting into the material of the subject. So what does it mean whenever people talk about temporal frequency and spatial frequency?
Okay, so that's a very good question. So we have frequencies, and fundamentally so actually let's get into lecture content so I have something to write on. But before getting into that and answering Eric's question, is there any other questions about the actual syllabus and grading or quizzes or anything at all? Okay, thanks, Andy. Usually we have fun the first day of class, and I play a game called DSP Roulette, and I think some of you have already seen that game in other classes. But we go through the textbook. We open the textbook to random pages, and I hand the student the textbook to. I probably couldn't do that even if we were in class, given no contact and all that kind of stuff. But I would have the student open the textbook to a random page, and we'd do this a few times, and we'd find out if there's a pattern. Well, if you open up your textbook to a random page, you'll find that page is most likely going to contain equations, mathematical notation, and all sorts of terminology related to math. Digital signal processing is an applied mathematics course. Signals are mathematical entities. Processing is operating on those signals, so it's math operating on math to generate new signals. And so there's a lot of math in this class, and this is essentially an applied mathematics course. So it's going to be math intensive. Having said that, let's talk about a little math. Oh, by the way, in terms of my background, I'm a math guy. So I have a degree in applied math from Brown University, master's degree. I also have degrees in computer science. I have degrees in computer science, applied math, and electrical, and 2 degrees in electrical engineering. Yeah, so I guess I have 5 degrees in total. And so, but this is a math thing. So this is a combination of engineering and mathematics. That's what this class is about. And so let's talk a little bit about frequencies. So Eric had asked a question here about spatial and temporal frequencies. And so if I write down x of t, this is something that we're all familiar with. What does this denote? This would typically denote a time domain function, right? Sorry, someone was going to help.
Yeah, no, I was just going to say time domain. Sorry.
Thank you for that. I appreciate that. By the way, class interaction is always at an all-time low online, which is sort of tragic. But I certainly appreciate those that decide to both share their screen, which is brave, as well as speak, which is also maybe even braver. So those are all good attributes. They're absolutely not required. Absolutely not. But they might help you engage with the lecture content better. So x of t, this is a function x. It takes on values for different values of the x-axis. So x of t, well, that we write that as a function, and the horizontal axis is time. And if something's a frequency, typically we think of a frequency as oscillating, all right? And so we represent the frequency as some kind of a sinusoidal function. Maybe we'll just call it sine of t. All right, so if it's a sinusoidal function, it will vary like this if it has 0 phase like that, right? So sine of t, if it has a non-zero phase, we might write it as sine of t plus phi, where phi is the actual phase. But note that every time that we write this, this t denotes something with units seconds. And so this is seconds is temporal. This is temporal, a temporal variable. It's time variable, and so just as singing a note, is a specific frequency in time, and so temporal variables like an audio signal would be denoted as a temporal frequency. In this particular case, this would go through one oscillation in 2 pi seconds. So here it would go through one oscillation in 2 pi seconds, and it would assume a value of 0 at 0, and at pi, and at 2 pi. And those would be the 0 crossings of the signal. And it would go on forever in both directions. Okay, when we talk about a spatial frequency, we are talking about something that has a different variable involved here. And so I'm not going to write it as x of t. I'm going to write it as g, and maybe I'm going to write it as x, g of x. Now this x variable is not time. This is space. Okay, so what is a spatial frequency? It's something that changes. In this case, it's a one-dimensional function. But I don't know if you've ever taken a rope and then wiggled it at one end and seen the transverse wave go across the rope to the other end of the rope. That is a frequency in space, because literally the position, the displacement of the rope vertically changes as the spatial variable. The distance along the rope is changing, right? So this might be a sine of x. So this is a spatial frequency, and in fact the only difference here is literally what is the x-axis. So here the x-axis is x, and we'll call this meters, and now we have a frequency in space, and it has the same kind of frequency. It oscillates 1 in 2 pi, but now 2 pi represents 6 meters, or a little bit bigger than 6 meters, right? So that's the deal with the difference between temporal and spatial frequencies. It's literally the difference between what is the unit of what is this frequency being observed, what are the units of this frequency, right? Is it varying in time or is it varying in space? And so, does that make sense?
Yeah, that makes a lot of sense, Dr. Willis. So basically, technically, just because we do a Fourier transformation to a signal, that does not necessarily mean that we're automatically going to put it in spatial frequency, right? Like in space domain.
Right. And so what makes sense? So when you take the Fourier transform, if I were to take the Fourier transform of this function, I would get a representation of the frequencies in time. If I were to take a Fourier transform of this function, the values of the frequencies, I get the representation of the frequencies in space. So the Fourier transform's interpretation is depends upon what are the measured units are. And so
Got you.
And so, say in image processing, if you have an image, so JPEG compression, I hope that we're all familiar with what a JPEG is, or a PNG image. What they actually are doing is they're taking the spatial transformation, they're taking the Fourier transform of that image in space, both in the X direction, which is across the different columns of the image, and in the Y direction, which is across the different rows of the image. So there you have a function of two spatial variables, X and Y, and what you end up doing is taking the two-dimensional Fourier transform. And in fact, the basis of all compression algorithms is this idea of taking that transformation. And when you do it, you find a very interesting property. You can actually do the compression in the frequency domain. You can actually throw out a bunch of information without making any perceptual changes to the signal, which is how compression works. And so image compression, you would take an image, you'd calculate its spatial Fourier transform in X and Y. You'd throw out information you don't think is important in the frequency domain, and then you would compress that signal. And that's what's happening right now with the very images that's coming across to your screens. It's all being compressed, and all of that. So I guess sort of leans towards how important signal processing is. So without further ado, we're at 2:00, and I want to address two things before we end lecture, before we start lecture. So those two things are actually these two links. All right, there's actually a survey on topic familiarity I'd like folks to go and take. And probably more important to you, so the survey is good for establishing sort of how familiar folks are with the topics before we start class. But also very important is this TA office hour preference. And so the preference for TA office hours is important for you to find places of time for the office hours, for Chang's office hours that suit your schedules. So everyone will have a vote, and we'll seek to find a collection of times that are as best as possible compatible with the times that you folks would like those TA office hours held. So I want to point those are your assignments. Go ahead and take the survey. The survey is saying it's closed? Let's see. Let's go ahead and TA office hour preferences. Is this closed? It seems like it should be open. I have 5 responses. Are you sure?
It's the exposure one that's closed.
Okay. So yeah, let me
The survey's on Canvas?
yeah, this one. Yeah, this one is not accepted. Sorry. So now this one should be available to you. Yeah. Thank you for that. I appreciate your prompt feedback, and I want to act on it. So now that should be open. Is it they should both be open to you? Now the links. Maybe they changed the links. The links should also be available here. On the front page. So this should be the topic exposure survey and the preferred TA office hour survey. So hopefully they are both available to you. Can I have anyone confirm that they have access to these?
I have access to the survey.
I have access to the TA office hours, but not the exposure survey.
Okay, could you try refreshing and see if you can access it after refreshing?
Oh yeah, I can now once I refresh.
Okay, okay, that was so. I did have to fix that up, but I apologize for that. Thanks for working with me, and hopefully those things will be error free now. Okay, so yeah, that's another thing. Like there's a lot involved with the technical execution of all these things. So bear with me while we navigate these technical space to make these things available. But what we're trying to do here is serve you folks as best as possible, given this online context. All right. Well, having said all that, we do have 10 minutes here, and I'm going to proceed with lecture if there are no other questions. Is there any other questions?
I have one regarding what you were just talking about, spatial frequency.
Yeah.
So I know you were just talking about, the unit of how we measure these frequencies. So I guess light traveling, would that be considered a space frequency considering?
Yeah. In fact, I do a lot of research in radar these days. And so the propagation of electromagnetic radiation at the speed of light is for sure a spatial frequency. And not only that, polarized light and everything, for those that are electrical engineers, just finished up their waves. Super cool stuff. That's a spatial frequency. In fact, in radar, you sample those signals at about 1 gigasample per second, or 1 gigahertz. You have an analog to digital converter, and they're going to put them in cars a lot these days. What's good about radar is you can see through things like smoke and snow and rain and all of that. That's all transparent to radar. It would block it would block your visible light cameras. So if you're trying to use visible light as a sensor to help drive a car or whatnot, it's going to have a problem when it snows or when it rains. And radar doesn't have such problems due to what they call Mie scattering. Mie scattering is the relationship of the wavelength to the objects that might scatter that electromagnetic radiation. So what's the point here? When you sample at that rate, it turns out that you're sampling the signal as the light propagates about 30 centimeters, 28 centimeters in one when you sample it at 1 gigahertz. So it's 1/100th of 1/1,000,000th of a second. That's how far it goes, 28 centimeters. For sure. You can actually measure its phase. You can see it go up and down, and it's pretty amazing. And you can actually sample it much faster these days. So it's very much a spatial frequency, and it has both an electric and a magnetic field, and you can see those fields oscillate when you measure them. And the phase of those fields and their relative magnitudes is the fundamental thing by which both visible light cameras work, as well as radar and all communication, like any wireless communication uses electromagnetic radiation to communicate signals. So yeah, great example of a spatial frequency for sure. A really cool one too.
Thank you.
So Dr. Willis, I guess whenever you're modeling the electromagnetic wave radiation, since it's a function of space and time, how do you deal with multivariable functions in signal processing? Do you isolate the variables and do like an analysis on each?
Yeah, you just list them. You just put them all in a list. In fact, Project 1 will have a function of both space and time, and frequency. Actually, we process a color image which has red, green, and blue components. So you've got frequency. Of course, red, green, and blue are all different visible light frequencies. So you've got a function, 3 different frequency bands. Then you've got time, and then you've got space. So we process an image, a video image. So if you think about a video image, just an image itself, say an image of this little green guy smiling, you designate the horizontal axis as X, you designate the vertical. Thank you so much, Santiago. Yes, you need to make sure you're logged in with your UNCC email, both to attend lectures as well as to access these materials. So thank you for helping me and other students, have success here. Thank you. So anyways, an image, we can designate the horizontal axis as X, the vertical axis as Y. And now we have the image itself will have different intensities. If it were a black and white image, we might write it as intensity as a function of X and Y. And so now we have a mathematical relationship. For any given xy position, let's say this one right here, this position right here, we'll call that position x0, y0. There'll be an intensity there. And we're going to write I0 is the intensity that we observe at x0 and y0. And now we have a function of space like that. So this is simply a function of space. At any given location in the space of the image, the xy space of the image, I can find an intensity. And I'm going to call that intensity I naught. Now you can also go on and say, let's say that we have a collection of images in time. And so we just tack that on. Okay, so now we just say we have a function of x and y, which is an image, but then we're going to index them with a new variable, t. And so when t is equal to 0, well, that's the first image. When t is equal to 1, well, that's the second image, so forth and so on. And now I can just write it in exactly the same way. Now I have a video. It's x, y, and t. And so you might write down a video sequence in black and white like this. If it were not in black and white, then the value you would observe at any x, y, and t location might actually be 3 variables, red, green, and blue, instead of just an intensity. So that's an example of just how signal processing, we just add dimensions. F of x, this is one dimension. We have one variable. F of xy, this is 2-dimensional. And f of xyt, this is now 3-dimensional. And so very commonly in our artificial intelligence applications and in many other contexts, high-dimensional like computer vision and the kind of things that the Tesla vehicles are doing, they're doing signal processing in hundreds of thousands, sometimes millions of dimensions. And that's okay. As long as you understand the concepts of signal processing and the mathematical theory that you're leveraging, this is all right. You're quite comfortable with this, and we can just keep on plowing. For example, just think of an image itself. If it were a 10 by 10 image, then the number of measurements in one image would be 100. And so the image itself would be a 100-dimensional vector. And if you thought about, say, 10 of them in time, so you have 10 by 10 images, well, and now you have a 1,000-dimensional vector. And you can represent entire sequences of variable values in very high-dimensional spaces. And it's this kind of this thought process, the concepts associated with that are pushing forward technology as it exists these days. So I don't know if that's as far as I want to go on this, but I hope that answers your question.
No, that definitely does. So that means that the degrees of freedom that we're going to be giving as an engineer are going to depend on our variables, right?
Yeah, the model that the mathematical models that you'll have are going to depend on these fundamental these variables that control everything. These designate different inputs essentially, and then this is sort of an output. So functions essentially take inputs and transform them into outputs. So if I give you an x, y, and a t, then the f will take those values and give you an I. And you can think of that an image as one of those things. It's just values of a function. I plug in some coordinate x naught, y naught, and it tells me what the intensity is there. So an image itself is the function f. It is the actual thing that gives a collection of values for a collection of spatial locations. All right, I'm going to go. Well, we've just got a couple of minutes. This is about me. You've already heard about me. I do stuff in computer vision, robotics, AI, machine learning, AI, radar, image and video processing. And I've been doing them for quite a while. I certainly enjoy them. This is my office. We already know about that. You've already heard and talked to Jin Cheng at the beginning of class while we sorted out some technical hang-ups. This is the actual textbook. It's Oppenheim and Schaefer's textbook. There are other textbooks. In fact, there's some great material available from MIT OpenCourseWare. And you can directly hear lectures from the 1980s. This is a classical topic from Oppenheim, the author himself, from MIT. There are other reference materials that have no cost to you, and these are links to those things where you can download them. And so the grading we actually covered in when we went over the syllabus, but I'm sort of restating it here. It does include MATLAB. There's a MATLAB tutorial here, and you'll have all of those MATLAB things available. Please attend the class. Attendance is not necessary. On homework, you're encouraged to discuss. You are not encouraged to copy the work of others. Do not copy the solution or spend most of your time looking for that solution using Google or whatnot. I suggest working on the homework and performing the solution yourself, because that's what you ultimately will need to do when the time comes for the quiz or the examination. Canvas delivered examinations in class if possible. I haven't updated so these are not right. So midterm is March 1. And then this is TBD. We don't know when this will be. So, in fact, this has annotations in it. How did this have annotations in it? That's strange. Okay, so course projects. You're going to use your DSP knowledge to solve a problem. It's going to involve MATLAB. And you turn in a project report. So this is information on MATLAB. Well, there's the online tutorial. There's the link where you can set up the free account. And MATLAB is free to students, so if you did decide you wanted to install it, you can install it. And so I rambled through that first part real quick. We're going to go to lecture 1, because I kind of presume that we actually don't get much time to go over it. So we'll go over the remainder of these slides in our next, so what's the project format? It's a PDF format, and in terms of the project, they give you a 2 turn-in section for every part. And so what I suggest, you're responsible for formatting your own responses. What I suggest is that you restate the question, and then you state your answer to the question, and then you move on, and you state those answers in the order in which the questions were posed. But again, it's your report, and so you have the freedom to designate your own format for how you report the answers to the questions. But that is my suggestion. So thanks for that question. All the projects are individual. The work that you do on the projects is your own work and should not reflect the knowledge of any other student's work on any. You should not have. That's academic integrity is something I feel strongly about, and something I will maintain. In fact, for the exams, when you come to the exams, if they're in person, I'll take attendance at the exam to ensure the people that are in the class taking the exam are the people that are taking the exam, and that you are there and taking the exam in the class. So those are other things. And part of the exams is like you'll upload your work for partial credit after the exam, because the exam itself is on Canvas, and it doesn't really reflect some of the partial credit you might receive from written stuff down on the paper. So I'm sorry I've run out over a couple of minutes. I apologize for that. But I do want to end lecture here now. We'll continue with this introduction to digital signal processing, tell you more about the topic area and the things that we'll be studying, and then we'll actually transition into actual lecture material in our next class on Thursday. People are welcome to stay behind. Yes, you will definitely need to not upload, but you will submit it as part of your project report. So the question came, do we need to upload MATLAB code we created on the exam? So on the exam, if it was if you want to receive partial credit, you should just, have it, capture it and put it in there. Most of the time students don't end up submitting MATLAB, but anything that tells me what you've done on the exam to solve the question is credible for partial credit. So I don't want to exclude it. So having said all of that, for those folks that are comfortable with this and have no further questions, you're welcome to go. I'll thank you all for coming. And I'm going to stay online for a little bit to see if there are any other questions. And of course, I do have office hours right after class. So at 2:30, I'll certainly be transitioning over to my office hour meeting, where that is another Zoom meeting you're welcome to go to if you have any other questions. Thanks for your comment, Nicholas. Very kind. There are no group projects or group work in this class. Everything that you do is yours. So every single thing that you do. So I'll continue to answer questions as I see them come up in chat. Thank you for your time, and have a good afternoon. So I'm going to stop the recording as well so that it can start doing its thing.